Hello, in this video we are going to look at a solution to question 3 from the 2016 AP Computer Science A for response section. We're going to start by looking at part A, and there'll be a video for part B, and I believe, if I remember correctly, there was a part C. Part A, part B. Oh, it's just part A, part B. Perfect. So there'll be a part A video and a part B video. With that in mind, let's dive in. So what this question's having us do is it's having us essentially write a class structure that allows us to kind of simulate a crossword puzzle. And the way it does this is it provides for us this class called the square class, which it doesn't show us the code for. Again, one of the things with the AP exam you want to get used to is the fact is they're going to provide code and say, I'm not telling you how this works, I'm just telling you that it does work, so use it. And then what we do is to make a crossword, we instantiate this crossword class, which has a two-dimensional array of square objects, which represents the puzzle. We have a constructor in here, and we have it to be labeled. And what this function to be labeled does is it determines whether or not we need to provide a label in a specific square. And what we mean by label here is, if you scroll up, is any square that has a number on it is required to be labeled. And we determine if it's labeled based on these rules. All right, so let's dive in. So if I take a look here at the square class, I've added a little bit to it, because in order for this to work, I needed to kind of add those things. So I made it a field called isBlack and a field called num, and all my constructor does is it takes whatever the isBlack is and assigns it, and the num and assigns it. Now, an interesting point here, just for learning, and this is something students often do, and it's one of those things that always pains me when they sit there for a long time and it just won't work and they can't figure it out. Sometimes what people will do is they'll match their field name and their parameter name. This isBlack and this isBlack are different. So if you have a variable or a parameter that is the same as a field, you can only access the field using the this modifier, because if I write isBlack, I'm going to assume it's the local variable that I'm accessing. So I have to say this.isBlack equals isBlack, this.num equals num. This is one of those things that my recommendation is, if you're ever setting fields, don't have your field names match your parameter names. It just avoids that kind of challenge. And I've also included in this a toString method, because I've actually coded this to kind of generate the board for us so we can see what it looks like. So let's pull up our crossword. There's our crossword. And you'll see if I run this, what it actually does is, this is my original crossword, and instead of spaces, I've put a white space using an underscore so I can see it, and this is the resulting board when I've numbered it. It's a little bigger because some of the two-digit numbers need to fit in there. All right, so let's scroll down here, and we are writing to be labeled. So how do we do this? Let's pop up this again. There we go. So again, always take a read of this precondition. This precondition is really important. It means that I don't have to worry about checking whether or not R and C are valid. I know they are valid, and that reduces my code quite a bit. So always read those preconditions, always read those postconditions. So what we're going to do is we're going to return true if the square at row RC should be labeled with a positive number, false otherwise. So if I come back into here, well, one way to approach this problem is to kind of sequentially go through the cases and make a decision. So the first thing I'm going to do is I'm going to say if black square at RC is equivalent to true, so basically saying, is this a black square? And if it is a black square, we are not going to give it a number, so I'm going to return false. Done. If R is greater than 0 and C is greater than 0. So this is dealing for, if we take a look at our board here, this is dealing with the section that's kind of in here, because the way the rule works is I'm going to look and check if there's a black square either behind it or above it. And if there's a black square behind it or above it, I need to give it a number. So if you take a look at this square right here, there's a black square in front of it, meaning that this has to be numbered. It's going to get a numerical value. And then all I do is I check the square to the left, and I check the square above. And if either of those are black squares, I return true. Case 3 is that if the row is 0, and what we can recognize here is if we look, if the row is 0, all of these have numbers. The top row is always going to have a number, unless it's a black square. So what I do here is I say if r is equivalent to 0, return true. Now you might say, well, wait a second, what happens if it's a black square, right? But remember, I've accounted for any black square right there. Anything past this point is going to be a white square. And then anything past this point is going to be a white square where the column is equal to 0. So I just return true after that. So this is one approach to this problem. Again, it's a nice little way of testing to understand that with a number of if statements, checking if students can write if statements such that they cascade, right? This first one is what I have to check first. If I do this first, I'm going to have a problem. Here's a better solution. I'm just going to scroll down. I'm not going to read all of this. If you want, of course, you can download the solution, take a read of this. This talks about short-circuited conditional statements, and that's really what this solution down here leverages, because it turns out, where's my, there it is. Turns out, oops, commenting issues. There we go. Turns out I can do this entire question in one line of code. Again, these are fun things to inspire towards, but don't put too much pressure on yourself to do these in one line of code, because, quite frankly, you're far more likely to make a mistake. And so essentially is I say if it's not a black square, because essentially if it is a black square, right, this is going to be, if it's not black square, means that this is going to end up being false. If it's a black square, meaning I'm not going to evaluate the rest of this. So this line here, and I'm not going to try and explain it because I realize it won't come out right now, is exactly the same as all of those other if statements, but condensed down into one line. So again, feel free to download the code and take a look at that and post any questions. If you really want me to go through this, send me a note and I'll take some time to do that. Okay, in our next video, we'll look at part B.